In this video, I'm going to teach you how to examine nonlinear effect or quadratic effect in SmartPLS. Before that, why do we need to check on nonlinear effect? Basically, in social sciences, we often assume that the relationships among variables are linear. However, there are many instances whereby the linkages among the variables is more complex than that. And as such, you might have nonlinear effect in the model. According to Augustine and Singh 2005, there is a growing interest among researchers in examining the curvilinear effect within the supposedly well-researched frameworks. That is also a good research contribution for many scholars. Here, we try to question what we think we already know about existing models and examine the nonlinear effect that might exist among the variables in the model. This is typically how a nonlinear relationship looks like. To examine a nonlinear effect in SmartPLS, there are a number of approaches. The recommended approach, of course, is by Hensler and colleague 2012, and it's called the two-stage approach. In two-stage approach, there are two major steps involved. The first one is running the main effect model to obtain the latent variable scores. For this step, we will of course not include the quadratic effect variable. After obtaining the latent variable score, the score will be used in the second stage when you're including the quadratic effect in the model. Here, all of your latent variables will be measured using the latent variable scores. To clarify this for you, I'm going to show you one example which involves real data with regards to ethical leadership. This model has three variables. We have ethical leadership as the exogenous variable, and we have two endogenous variables named ethical climate and followers empowerment, and all of the variables in this model are measured using reflective scales. Following the guidelines by Hensler and colleagues 2012, in running the two-stage approach, we first run the PLS algorithm to obtain the latent variable scores. After running the PLS algorithm, we refer to the report to obtain the latent variable scores. On the arrows, you can see that we have the regression weights, which are positive here, and they are considerably large. To measure whether they are significant, we can also run bootstrapping. In this instance, we only need to refer to the latent variable scores. So just click on latent variable score and open up the report page. All you need to do is to just copy all these latent variable scores and paste them into an Excel sheet. Then of course you can rename it according to the variables: ethical leadership EL, ethical climate EC, and obviously followers empowerment would be FL or FE. Then the next part is that you can save this into the acceptable format required by SmartPLS, which is .csv, delimited. And in SmartPLS, then you need to create a new model with the latent variable scores. This is the second stage in our two-stage approach. Here we draw a new model using the new data set, which is the latent variable score. As such, all of your latent variables will only have one indicator, which is the latent variable score obtained from the step 1. Alright, there you go. So before running the model, you also need to add the quadratic effect variable. In order to do that, you need to choose the variable of interest. In other words, in this case, ethical climate would be your DV, because you want to see whether ethical leadership has any nonlinear effect on ethical climate. Therefore, right-click on ethical climate and choose Add Quadratic Effect. In the new window that pops up, just choose ethical leadership as the independent variable, and then we are going to use the two-stage approach, and the rest of the advanced settings you can just use as the default. So the quadratic effect will be added to your model. All you need to do now is to run PLS algorithm and look at the regression weights obtained for each of the paths. In order to check whether this regression weight is significant, you can run a bootstrapping approach. So these values can also be included in your model. I can use these values in writing the equation for my quadratic effect. So in this case, what I understand is that ethical leadership accelerates the creation of ethical climate within the organization. And when you check the significance level on the values on your arrows, you will see that the quadratic effect has a significant impact on EC. However, I still would be able to question that to see whether it has any practical value. To confirm the practical value of this quadratic effect and its inclusion in the model, what we can do is we can run the effect size, we can examine the effect size for the inclusion of the quadratic effect. This formula allows you to examine the effect size, which says effect size equals r squared for the model with the nonlinear term minus the r squared for the model without the nonlinear term divided by 1 minus r squared for the model with nonlinear term. Well, if you find this equation and calculation complicated, I've created one Excel sheet for that purpose, which allows you to just simply copy and paste the values of the r squared, and it will tell you what is the effect size. So let's just quickly run PLS algorithm one more time and key in those values in the Excel sheet. So this is with the inclusion of quadratic effect, and the R score is 0.479. So I place it there, and then I have to remove the quadratic effect for the calculation of the model without the quadratic effect. This is the R square without the quadratic effect, which is 0.318. As such, when I press enter, you will see that the effect size here is 0.31, which is within the moderate range because it's larger than 0.15. As such, I can conclude that quadratic effect has a moderate effect on this model, which is quite considerable and could be a good research contribution here. Now, if you find calculation of effect size confusing, I would be happy to send you the file. Just feel free to send me an email. And here are some references for your attention, just in case you need to read more about these.